Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about the commit protocols, two-phase protocols in details, and now we will show some extensions to can move to the three-phase protocols or 3PC. As we know that the transactions we are dealing in a distributed nature, that means that many of the sites can perform the same transaction on the same database, and all of them need to be committed so that a final commit on the transactions. Now, how that we can achieve this type of commit protocols? So this can be achieved with the two-phase and three-phase protocols known as the commit protocols. When we have finished the transactions in each of the sites that is belonging to the distributed system, then only we can say that we are having the commit protocols on this site. So now many of the applications are there to perform these commit protocols. The first one that we will discuss today is a two-phase commit protocol. In the two-phase commit protocols, it just requires that every site that is intended with the transaction that we need to complete must be completed from each of them, and until and unless we cannot proceed with a commit T that is even in the log record. So to continue with this protocol, we first need to show the algorithm that how we can be implicated with this type of algorithm. So there are two phases on which the commit protocols inside a 2PC environment can be achieved. So we will discuss the phase 1 first. Say suppose that we have initiated the transaction T at site SI where CI is the coordinator of that site. That means SI is the coordinating site, while the CI be the coordinator. Now at phase 1, we just need to inform to CI that every transactions or the T that is completed with each of the sites. So if there are sites belonging to S0 to Sn, then the CI must get a message to this T that from S0, Sn, S1 until and unless we are getting this SI. So including the SI, all of the messages must be passed to the CI that TI has completed. It is not committed, that is completed their portion of this work. So finally this message just decides that which portion on the site that the transaction it needs to complete or not. By sending the message, it initiates that we are ready to complete the transactions in this site. So this message T is generally by complete T in SJ. That means in every SJ which belongs to S. Now if the answer to this message is no T, so there is a message that is go with no T. Now after CI gets any of the no T to this message that is belonging to SJ, now it needs to check. Now when it is a no T that the message is sent to the CI, that means it is sended by the message with abort T. That means if it is a no transaction log record that it is maintaining, that means it is placing the abortion on that message from the CI. Now if it is an yes, then it places a ready T to this message T. That means now my SJ is reading the message to the CI, to the coordinator, that it is ready to complete its transaction. So the question by this message was that if the transaction is ready to complete or not, that is complete T. So if we put a question mark here, then the answer will be no and yes. With the no, it will get the abort T, and with the yes, it will get the ready T. Now the confirmation on the coordinator, it has from every SJ that belongs to S that either they are ready to complete or they are not ready to complete their transactions. Now CI generates a prepared T to get to the message to every SJ to get an abort T or ready T as its response. So now CI sends prepared T message. Now there are three options to this prepared T. One it is yes, that is with the ready T. One it is no with the abort T. The another is it waits for a specified period of time. That means after CI has initiated this prepared T message and sends and waits for the receiver or the SJ that to wait and check that transaction is completed or not, or it wants to complete or not. And if it doesn't get any reply from this transaction or the prepared T reply, then it will take this as an abort message from the SJ. So if it is not getting in the stipulated time, then the abort T message is considered to be the reply for this prepare T. So if it is an abort T that the ci.reply prepare T is getting, then it maintains a log record of aborting T. See, if any of the SJ is having the abort T message, that means if it is delayed or it is a no T to the complete T request, then it will be aborted by the transaction in the log record. No matter that if everyone except that particular site wants to complete the message, if anyone is not willing to transaction complete, then it will be aborted for the transaction. So that is the help of a concurrency control mechanism in this transaction commit protocol. Now if it is an commit T or this complete T or the ready T, then it adds an commit T to the log record. See, it is only maintaining a log record, not updating the database. Now that CI has added the log record abort or commit T, now CI will send every SJ that either an abort or commit based on the condition that if it is an abort or ready T condition. So now if it is for the SJ that J belongs to 0 to N, that means all the suppose the sites that is having the transactions. So if it is in commit T, that means the CI will send that the transaction is going to commit, and if it is an abort T, then CI is going to send that transaction is going to abort. So now that the transaction on the site gets either the abort and commit request or the information being conveyed to them. Now a site at which the T is executing can either uninformedly abort a transaction before sending the ready T to the CI. That means now my transactions can be aborted onto the site that is locally either before the transformation has been compared and completed to the ready T. That means whenever we are having the completion of a transaction, it can be a successful and unsuccessful both the completion. So if a transaction is terminated by the site locally and now it is sending the ready T message, that means actually it is sending an abort message. Say suppose that every transactional site which is conditioned on the transaction and make an unconditional abort on the transaction, that happens before the transaction is shipping on this ready T message to the coordinator CI. So now it need to update the stable storage. Before that, if when it is sending an ready T message, that means the site is going to the ready state, and whilst the site is going to the ready state, it cannot change its confirmation. That means it is the confirmation for the local site to the coordinator that the transaction has been completed or is going to be completed. So either if it is a abortion or is in commitment, we need to update the stable storage. Otherwise, if after the ready T is sent by this local SI and then the system crashes on SI, then we cannot have the promise that after ready T has been sent, the T needs to be updated or committed. So how we can do that? Now see that for every site, that is the level storage of that J is equals to local. That means they are updating their local stable storage, not the other site's information. Now if it is the local and the message is ready T, then you need to update from the local storage that the ready T, whatever it is unconditional abort that we have already sent to it, and if it is in commitment or an complete abort, then also we need to update the storage local. Now before the system crashes with the ready T is sent to the SI or the CI, then we can say that there will be no problem as SI is already being updated with the abortion or the completion of the transaction for this site. Now if any of the site that is being sent with the abort T, so if there is one message that is going with the abort T, then we need to break the loop. That means we do not need to check any further. If it is the first node that is making the abort T, then we need to break the loop and makes the abort T inside the final commitment. Now after that, for each of this site which receives the abort T or commit T from the coordinator, upon their reply to the coordinator's prepare T, if it gets a commit T and it says that it has completed, then it sends an acknowledge T from the site on this to computer coordinator. Now, if the coordinator get for each of this message that the SJ is containing to acknowledge T, then only it can commit T and finally says that T has been completed. Other than that, it could have been break for this two-phase locking protocol. So the acknowledge T is the final message that we can get for this two-phase locking protocol. So in this way, if the local site as well as all the server sites are acknowledged that they has committed the protocol, then only the transaction can be committed. Other than that, it will be aborted. So this is the algorithm for having the two-phase locking protocol. Now the next part is how can we handle this two-phase locking protocol if there isn't a failure. So there are many cases on which we need to check the failure and recover from it if it is a problem with the transaction and also with the coordinator. Now how is the failure of a site affects the two-phase locking protocol? Say we have two conditions to define our failure. The first one is that the transaction on the site fails after the ready T message is sent to the site on the coordinator. Now when the coordinator gets the ready message, that means we are getting in the portion of the two-phase locking protocol where we have seen that the transaction is already being made its local update to the stable storage before the ready T is being sent. So if there is any unconditional abort by the site before the ready T is sent to the coordinator, then it will automatically update the stable storage. So can the coordinator get the idea of what the update it is having, an abort or an commit. But if the sender or the site on which the participator is being used is being failed after the ready T message is sent, then the coordinator just ignore the failure of the site and just ensure with the rest of the commit protocols without being fetched that the SK has been already failed. So now how we can construct this one? Now the first part goes with the two-phase locking protocol where we are having that the unconditional abort if it is T, and that is the timestamp having the ready T's before. That means now my failure is being sent before the ready T, which is being go to the coordinator site. So now we can directly update the SJ's local storage about the failure. Now what happens if it does not go and the ready T has been already sent to the coordinator? Here the term else specified that it is greater than this TS. So now other than that, the CI will final update with the complete T because it just ignores the failures on this SJ. Now say that the failure has occurred after the redo or this particular ready T statements. Now the Locti can contain many of these possible conditions. We will discuss each of these conditions. Now if we need to the log T, which goes with the commit T, that means there is one start T and one commit T. As with the log based recovery technique, we know that if there is a start T and commit T both belongs to the log, then we need to redo the transaction. Now the CI needs to redo it because it's got both the commit protocol and this start protocol. If the transaction has this start and abort protocol, then we need to undo the transaction. Now the next is the TI is not containing in the log commit and abort. We know that other than commit and abort, it is containing other message that is in ready T. That means now my log contains a ready T command. Now if it is containing the ready T, then it can have two situations. That the ready T is being sent by this sender or the site on the participating one. Now if the CI is server on this upside, that means the CI is now active. So what it can do, if the CI is active, then it can choose from the commit and abort based on the redo and undo. So if it is in ready T that is received by the CI, then again we need to perform this commit T and abort T to go for the ready and undo of that particular transaction. Now if the CI.server is active, now if it is the commit, then we will redo, and if it is an abort, then we will undo. Now if the server is down for the coordinating site, then what happens? Then every SK that belongs to the SJ, that means the site needs to decide the fate of the transaction. Now the coordinator cannot decide because it is now at the downside. So the participating side will decide that either it will be committed or aborted. Now how can a participating site can decide which is not the coordinator? Then the participating site sends the query status on this T. That means now it needs to go for each of the status on the query that is being performed by the other sites. So other than the SK, every SJ needs to send their query status on request by this SK that they have completed the query or not. If it is considered that every query has been completed by every other site, then any of the participating site receives all the message and then it can commit or abort deciding on that situation. So now it sends the query status to SJ. Now based on this condition, the query status and periodically checks it after a time interval. Now finally, if my log is of no record, that is no abort, commit or ready, that means the transaction SK has been failed to respond before the stipulated time it's over. So now CI had sends the prepared T and for response time is gone. That means the interval for which the CI waits for a response, it is now over. So SK has not responded. Now my log requires no records in it. That means it can be computed that the SK was failed to complete that transaction at that point of time. Now SK need to undo it as well as CI needs to abort it. That means if the message is not done and not received before the timestamp has been already over, then SK must undo it and CI must undo and abort it. So this is the failure recovery if a site fails. Now the next one that we will discuss is the most important one, that if the coordinator fails to recover from a situation, then how can we handle the exact scenario? Now say if the coordinator fails in the midst of a transaction, that it gets some of the replies and some of the replies is yet not received and it just fails its operation. Then what happens? Then each of the participating site must decide the fate of the transaction T. So now the transaction will be decided by either it is committed or aborted by any or each of the participating site. Say suppose that any of this status on this SJ is active. That means the participating site is active and also the log is containing the commit T. Then the transaction must be committed by that participating site. Now if it is an active and not an commit, that is an abort T, then it needs to be undone or aborted the transaction by this site. Now what happens that if the message contains ready T, that means the log is not having commit and abort but an ready. Ready means that each of the participating site has sent the CI and ready message, but the CI is failed now. So the supposed active site on this participating SJ is have to the already status on this status or the site that is belonging to the other participating problem. Now if the SJ is active and also it has not sent any ready T to the coordinator and the coordinator is failed now, so the coordinator is of no duty, but as the ready T is not sent by any of this active state, that means we are considering that the transactions cannot be committed. Now either by the SK or the SJ, which is the deciding or the participating site now, can either commit or the abort it, and other than it can wait for the coordinator to get revived and take the decision to either commit or abort it. So the SK in this case cannot commit it, only it can abort it or wait for the CI. So if it is the abort T, then it can either abort it or it can wait for the coordinator status to get again active. Now if it doesn't contain the log record, either the ready, not commit and not abort, then the coordinator is failed. How we can handle this situation? Now if the site contains a log record that is ready T, that means either it can have the commit, the abort, and now it is not having the ready T, and the final case is the site that is active is having the ready T. So if the coordinator is not getting all the ready message, then no way it is possible to take the decision by the coordinator that the committed transaction will be made commit or abort in the log until and unless it becomes again revive. So the coordinators need to wait for this every active status site. Now every of the site that needs to wait for the coordinator to revive again, now there can be two conditions hold. One is the blocking condition for the coordinator. Now what is a blocking condition? Say suppose while the site that is active is holding a lock onto the data item on which the transaction was performed, it holds until and unless the coordinator revives. Now what happens that it is holding the lock so that other transactions on other sites cannot gain this lock or use the data item. Say suppose the coordinator has revived and then say the transaction needs to be aborted. So the holding lock just go unused because now the transaction will not get any effect. And this condition is not as a blocked condition. Well, it is an undesirable one. And other than that, the second option is the transaction on the active site is release all the locks that it had on the data item. So in these two ways, the coordinator problem with the failure can be survived and recovered by this supposed and participating site. So now if SJ is holding the lock, then CI goes in and blocking T, that the CI will decide that until and unless it will get revived, it will be committed or aborted for the transaction. And if it is not, then it will release the lock on queue so that other transactions can get the lock and the data item. So now we know that the condition on the failure of a site and failure of the coordinator. Now there is another condition that arrived at the network partition. Now if we partition the network in such a way that one partition gets all the coordinator and the participating site that is being harmed with this coordinator. So now there is no problem because the site that is having problem or the partition that is having problem is in the other part of this network. But if there are two partitions and one partition contain the coordinator and some of its participating site, the other one is having other symbiotic site, then it have the blocking condition of the coordinator failure and then the site failure that we have just described. So for the network partition, it is important to note that in which partition all the coordinator and the supporting sites are remaining. So these are the problems and the recovery from the two-phase locking protocol. Now the three-phase locking protocol differs from this two-phase locking protocol in that way that it checks for the coordinator not only the blocking site by just adding and supporting site to the coordinator. So now the again two-phase locking protocol need to be performed against all the two-phase mechanism, along with it has to check for the coordinator and the supporter which is being supporting the coordinator for the again two-phase locking protocol. So now it will be three-phase in that way. First the coordinator and supporting site or the participating site and the supporting coordinator and the participating site. So there will be two-phase locking protocols that we need to compute. So that gets some avoidance with this blocking one because now the supporting coordinator can check for if the coordinator fails. So that is all for the commit protocols. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.